Inside every CPU, beneath the metal, beneath the silicon, beneath the layers of engineering and design, there is a rhythm. A quiet, steady pulse that repeats without hesitation. It is not a sound you can hear, but it is a motion you can feel in every digital moment. This rhythm is the cycle that drives everything your computer does. It is the invisible heartbeat behind every app you open, every window you drag, every frame in a game, every calculation, every decision, every tiny piece of digital life. This rhythm is simple in structure, but enormous in impact. It moves through 3 steps: fetch, decode, execute. Over and over, billions of times every second. It is the loop that never stops, the engine that never sleeps, the silent choreography that turns raw electricity into meaningful action. In this episode, you will follow a single instruction as it travels through this cycle. You will see how something as small as a pattern of bits becomes something as powerful as behavior. You will watch it move from memory to understanding, from understanding to action, and from action to consequence. This is the rhythm of thought inside the machine, the place where intention becomes reality. An instruction is the smallest unit of intention inside a computer. It is a command, a tiny sentence written in binary, a message telling the CPU exactly what to do. It might say, add this number to that one, or move this value into that register, or compare these 2 values, or jump to another part of the program. Each instruction is simple, direct, and precise. A program is nothing more than a long list of these tiny commands. Thousands, millions, sometimes billions of them. Each one is a step in a larger idea. Together, they form the logic of your apps, your games, your operating system, your entire digital world. But the CPU does not see meaning the way you do. It does not understand add or move or compare in a human sense. It sees patterns of ones and zeros. It sees structure. It sees encoded intention. And from those patterns, it performs the work that makes everything function. An instruction is small, but it is powerful. It is the atom of computation, the smallest piece of thought the machine can act upon. And when billions of these atoms combine, they create the digital universe you interact with every day. The instruction cycle begins with a location. The program counter, a tiny register inside the CPU, holds the address of the next instruction. It is the pointer that guides the CPU through the program, step by step, moment by moment. When the cycle begins, the CPU reaches into memory and retrieves the instruction stored at that address. This is the fetch phase. It sounds simple, but it is one of the most important steps in the entire process. Without fetch, nothing else can happen. But memory is far away compared to the CPU. Not physically far, but electrically far. The CPU operates at incredible speed, and main memory cannot keep up. So the system uses caches, layers of faster, smaller memory, to keep instructions close. L1, L2, L3. Each layer is a little slower, but much larger than the one before it. When the CPU fetches an instruction, it hopes that the instruction is already in one of these caches. If it is, the cycle flows smoothly. If not, the CPU must wait for the instruction to travel from main memory, and that wait can be hundreds of cycles long. Fetch is the search for the next command. Is the CPU reaching out into the world, pulling in the next piece of intention, and preparing to understand it? Is the first step in the dance. Once the CPU has fetched the instruction, it now holds a pattern of bits. But what does that pattern mean? This is the job of the decoder. The decoder is a specialized circuit inside the CPU that reads the instruction, breaks it apart, and identifies its purpose. It determines whether the instruction is an addition, a movement, a comparison, a jump, or something more complex. It identifies which registers are involved, which data is needed, and what the CPU must prepare for. Decode is the moment where raw binary becomes intention. Is the CPU understanding what you want it to do? Is the translation of structure into meaning? Without decode, the CPU would have no idea how to act. With decode, the CPU gains clarity. This phase is not just technical, it is conceptual. It is the moment where electricity learns meaning, where the machine interprets your instructions and prepares to bring them to life. Now the CPU acts. The ALU, the arithmetic logic unit, steps forward. This is the engine of computation. If instruction is mathematical, the ALU performs the operation: add, subtract, shift, compare. If instruction involves movement, data flows between registers. If the instruction is a jump, the program counter changes direction, and the flow of the program shifts. Execute is the moment where intention becomes reality. It is where bits become behavior. is where the CPU does what it was told. This phase is the culmination of everything that came before it. Fetch brought the instruction in. Decode gave it meaning. Execute brings it to life. And once the action is complete, the cycle begins again. Fetch, decode, execute, over and over without pause. Registers are the CPU's closest memory. They are tiny, fast, and essential. They hold the values the CPU needs right now: numbers, addresses, flags, results. During the instruction cycle, registers are the actors on the stage. They store inputs, hold outputs, and carry data between phases. Without registers, the CPU would drown in delays. Every operation would require reaching out to slower memory. But with registers, the cycle flows smoothly. Data is always close, always ready, always waiting for the next instruction. Registers are the hands of the CPU. They hold what matters in the moment. They make computation possible at the speed of thought. Every action has consequences. Every calculation has a result. And the CPU keeps track of these results using flags, tiny bits that describe what just happened. The zero flag, the carry flag, the overflow flag, the negative flag. Each one tells a story. Was the result zero? Did the operation overflow? Was the number negative? These flags guide the next instruction. They influence decisions, branches, loops, comparisons. They shape the flow of the program. Flags are the CPU's reflections, a record of the past used to shape the future. They are small, but they are powerful. They give the CPU awareness of what just happened, and that awareness drives the next step. Fetch, decode, execute, again and again, billions of times every second. The CPU never stops. Each cycle is a tiny step forward. Each instruction is a piece of a larger puzzle. Together, they create movement, interaction, experience. The instruction cycle is the heartbeat of the machine, a loop that powers everything, a rhythm that never breaks, a dance that never ends. You have followed a single instruction through its journey, from memory to meaning, from bits to behavior. This cycle repeats endlessly, driving your apps, your games, your world. In the next episode, you will see how the CPU does not wait, how it overlaps work, how it pipelines, how it stays fast by never stopping. The journey continues until the next instruction. Thanks for watching, and I'll see you in the next chapter of this digital adventure.